Hello everyone, I'm Yusuf İsmail Okur, and I'm going to propose you my project. And its range on a tilted air table, predicting the impact position of a spring launched puck. In this experiment, we use a tilted air table with a horizontal spring mounted at the upper left corner. When the spring is released, it launches a puck along the x-axis with an initial speed. Because friction is negligible, the puck continues to slide down the incline and accelerates steadily in the downhill direction. Our goal is to measure how far the puck travels on the table and compare it with the distance we have uh, gotten with the theoretical prediction. This allows us to test how energy from the spring translates into motion on an inclined surface. Here I measure three things. First one is the range the puck falls. Second one is the height it fell from, and the third one is the compression of the spring. And we will use all three of these along with the sine theta of our incline, the gravitational force, and the mass of the puck to calculate our results. Here are all of my measurements as well as the gravitational force, and the sine theta of our inclined plane. In this part, to estimate the spring constants, I placed a 1 kilogram mass on top of each of the three springs and measured how much they compressed. Based on these compression values, I rounded their spring constants to the approximate values shown in the table. After doing this experiment 3 times on each spring, I've calculated the mean range. I'll use that mean range to calculate the error with the theoretical range. Here you see I used the energy relation and kinematic relation to calculate the initial speed and the theoretical range. And after comparing theoretical range with the mean range, I've gotten an average error about 40%. In this experiment, there are several factors that likely contribute to the relatively large percentage errors. First one being the springs constants were only approximates because I estimated them by placing a 1 kilogram mass on each spring and rounding the values. Any inaccuracy in these estimates directly affects the theoretical range. Secondly, the motion on the air table was not perfectly frictionless. Even small amounts of friction can cause differences. And third reason being the puck might not have been launched perfectly horizontally each time, and also because I had to launch them by my hand, there could be slight differences in there as well. And finally, there could be some measurement uncertainties. So thank you for listening to me and have a good day.